Hi, in today's lesson we're going to be discussing Kepler's laws, specifically Kepler's second law, in which case he describes the path of planets in a mathematical way. Let's quickly discuss those three laws of Kepler's. The first one is that the orbit of planets are ellipses with the sun at one focus. So in law 1, as we can see here, we have the sun in not the center, but just offset of the center of the orbit of planet Mercury. And you'll notice it's not quite a circle. It's just barely an ellipse. So although the planetary orbits are very close to circular, they're not quite circular, which is what confused people for many thousands of years. When they went to study the planetary orbits, they thought they were circular, and they were so close to circular that it made it possible to have that error in their measurements, and they needed to describe it in another way. Now, previous to the Kepler's laws, these ways of kind of managing this with the geocentric model included things like epicycles, as we've discussed in class, but Kepler was the first one to realize that these were not circular orbits, and that was the result of his adoption of Tycho Brahe's data set, which he actually stole from Tycho Brahe upon his death. So we are going to exaggerate the elliptic orbits of the planets like we have here in Law 2, just to be a little bit more clear with what the meaning of these laws are, but keep in mind at all times that the actual planetary orbits are much closer to circular than in these diagrams like Law 2 is showing. So Law 2 says a line from a planet to the sun sweeps over equal areas in equal intervals of time. So equal areas are located here in blue. So you'll notice this is an area between point A and point B, and on an equal period of time, the planet would move across the outer portion of this orbit from A prime to B prime in a shorter angular distance, but if you took the area of this, it would be equal to the area of this. So equal areas in equal period intervals of time. The third law is that a planet's orbital period squared is proportional to its average distance, which is the semi-major axis, from the sun cubed, which is the mathematical law that we are going to be using today for your calculations. In Law 3, the A value is the semi-major axis, which is this distance right here. It's not necessarily a radius, because remember, a radius is only for a circle. This is an ellipse. So this is to this portion on the ellipse, similar to a radius. So the period, P squared, is in years. The semi-major axis cubed is in astronomical units. Now remember, the astronomical unit is the distance, the average distance between the Earth and the Sun. So that's what we use for A, is the average distance from the Earth to the Sun. Now this is going to vary with planets that are closer to the Sun than the Earth is, like Mercury and Venus. This, of course, the A would be smaller than 1, and for the Earth it would be equal to 1, and for the planets outside of Earth's orbit it would be over 1. So let's keep that in mind. So for the first example here, we have Mercury's orbital period given to us is 0.24084 years, and we're asking for what is the average distance from the sun, which is A. Now, in order to make this actually work, we're going to have to set this problem up using a cube root, right? So we've got to get a by itself. So what you want to do is you want to say 0.24084. We're going to then square that value. Once you've squared that value, then you need to take the cube root of that value to find a. Okay? On the other side of this equation, if we have P is what we're looking for, we're given A, like in problem number 2, Venus's semi-major axis, A is equal to 0.7233 AU. We're going to cube that value, A cubed, and then we're going to have to take the square root of that to get P by itself. So we'll take 0.7233, we're going to cube it, and then take the square root of your answer to find P by itself. Okay? So if you have any questions about this, please do not hesitate to contact me via email or in class. And after you submit this on Schoology, then all you need to do is check the key, and I'll provide the key for you. All right, thanks a lot, and have a great rest of your day.